Okay, this is lesson 14, factoring special cases and non-factorable trinomials. Okay, students will factor special cases and identify non-factorable trinomials. Okay, so today the goal is to look at special forms of trinomials where you're like, oh, I remember this when we multiplied it together, it was a shortcut, right? So isn't there a shortcut to undo those special ones? Yeah, there is a shortcut, because if you recognize it, you'll be able to go more quickly, right? We always want to save time, right? Yeah. Raise your hand if you want to save time. Yeah, I want to save time, right? I don't want to be working all day. I'd rather do shortcuts, okay? So, and then there's sometimes non-factorable trinomials where you're going to get frustrated. You're like, there's nothing that works in my X box. This isn't a perfect square. This isn't a difference of squares. So you just kind of leave it as is. That's it. Okay? So here we go. Here are the steps. You should have them written down. If you're in the video, pause it now. Here we go. Number 1 and 2. Watch carefully. Factor completely. Number 1, 9n squared minus 30n plus 25. Okay, so back in the day, a week ago, okay, we talked about a form look like this. A squared plus, if we had something look like this, a plus b times a plus b, it's going to look like this form. This was last week. Raise your hand if you kind of remember this from last week. Okay, good. This is a perfect square. Two binomials being multiplied together. Okay. So, when we look at a number 1, we could go backwards. I look at number 1, it says 9n squared. 9 is a perfect square, and so is n squared. And 25 is a perfect square. So, if I have a trinomial, I want to check to see if this middle term works as 2ab, which means 2 times a times b. So a here is 9n squared, but we want to know what's the square root of 9n squared. Well, the square root of it is 3n, right? And the square root of 25 is positive 5, right? But it could also be negative 5, and I'm going to choose negative 5 because my middle term is negative, okay? So the way I check to see if this is a perfect square trinomial is I'm going to multiply 3n times negative 5. What's 3n times negative 5? Negative 15. And then remember we have to multiply by 2. What's negative 15n times 2? Negative 30n. So that works. This means that this is a perfect square trinomial. So usually I do this in my head. I don't write all this down. So what I just do is just make 2 parentheses and take the square root of 9n squared, which is 3n, and square root of 25, which is negative 5. And then I'm done. Okay? That's my answer. Alright? So what did I do just now? I recognized number 1 was a perfect square trinomial. Took the square root of 9n squared is 3n. Square root of 25 is negative 5. I know it's negative 5 because this middle term is negative. And I multiplied 3n times negative 5 is 15. Multiplied by 2 because that's the form. Equals negative 30. And I did that in my head. Okay? Then I wrote 2 parentheses down. That's my answer. Yes, sir?
How would you do it if you had 4?
4 what?
Such numbers up there.
It wouldn't work. This is a special case when there's like, if you see this form, then you don't have to do Xbox. Could we still do Xbox on this problem? Yeah, you could still do it. Can you do Xbox? Yeah, so if you don't remember the form, yeah, do Xbox. Will it take you longer to do Xbox? Yeah. I'm trying to teach you the shortcut. That's the goal for today, teaching you the shortcut, okay? If you miss today's lesson, is it going to kill your grade? No, you can still do Xbox, okay? But it's going to take you longer. Number 2, watch carefully. Number 2 is a difference of squares. It's a different form. So we have 25x squared minus 16. So I remember last week that when I had 2 numbers, let's say it was a plus b times a minus b. What's my answer? A squared minus b squared. Remember this last week? Okay. Today, we're looking at it backwards. So first term is a perfect square. What's the square root of 25x squared? 5x. There's a minus sign in the middle. What's the square root of 16? 4. Okay? So then all you do is you just make 2 sets of parentheses. Square root of 25x was 5x, so I'm going to write 5x here. 5x here. Square root of 16 is 4, so put 4 and 4. Put a plus sign and a minus sign, and I'm done. That's it. And I know this is the right answer because it fits the form. If I were to multiply it out, it'd still be the same answer. I could check my work. Okay. Can I still do Xbox on number 2? Yeah, what's A?
25.
What's B?
Negative.
0. Is there a B? No, so what is B? 0. What's C? Negative 16. So could you still do Xbox? Yes. But do you want to do Xbox? No, because it's going to take you too long. Why don't you just do the shortcut, right? Any questions on these two shortcuts? Okay, cool. So turn to your neighbor. Let's have 2's tell the 1's about number 1. 1's tell 2's about number 2. Ready, set. Okay, so number 3, let's do together, okay? So turn to your neighbor. Tell him, do you think this is one of the forms? And tell him which one it could be. Perfect square or difference of squares? Remember, difference of squares, you end up with a plus and a minus sign. Perfect squares when you have the same thing, plus and plus, or minus and minus. So perfect or difference? Which one? Perfect. Perfect square, okay. Perfect, not difference. Difference of squares is when you have a perfect square, and a minus sign in the middle. Okay, so got 4x squared. What's the square root of 4x squared? 2x. Okay, so in our head we're thinking 2x, and then let's look at the last term. Square root of 1? 1. But this middle term is negative, so
Negative 1.
good, negative 1. So let's check it. We have to do a 2ab. Okay, what's 2 times negative 1?
Negative 2x.
Negative 2x. Negative 2x times 2 is?
4x.
Negative 4x. Does that fit our middle term? So is this a perfect square? Yeah, so when it does this, you don't have to do Xbox. You just make 2 parentheses. Take this perfect square of each one, put 2x here and 2x here. And then negative 1, negative 1, okay? That's all we're doing. Still don't get it. Okay.
I don't get what we done the last part. No, never mind.
What? We're factoring. Remember, we're breaking it apart. Remember last week we multiplied binomials together? Okay, last week we started with this, and then we ended off with this, right? Remember that? Yes or no?
Yeah.
I hope you do, because we have a test on it next week. Okay? This week we're starting with this and going backwards. Okay? What happens to the middle number? It just disappears because we're breaking it apart. Okay? Because if I were to multiply, what's 2x times 2x? 4x squared. What's 2x times negative 1? Good. What's negative 1 times 2x? Good. What's negative 1 times negative 1? Good. And then I simplify 4x squared minus 4x plus 1. That's my answer, right? That's multiplying, right? But what are we doing today? What are the directions at the top say? Factor. So are we doing all this multiplying business? No. Okay? Are y'all following what I'm doing right now? Okay? Because some of you are looking at me with like glazed looks, glazed eyes, like donuts. Might as well put sprinkles in your eyes. Okay, here we go. Number 4. Number 4. This is a perfect square. It should be, right? Go. All eyes up here. You got 5n minus 4 times 5n minus 4. That should have been your answer, okay? Yes? What's another way to write this? Check this out. I saw some of you do it. But you could also write your answer like this. 5n minus 4 squared. Is this okay? Yes, it's okay. Okay? Number 5. Okay, this is a different form. What form is this? Last one was called perfect square. What's this one?
Difference.
Okay, good. So let's do this one together. Is the first term 81n squared? Is that a perfect square? Good. Is the second term 121 a perfect square?
Yes.
Good. What's the middle term? Is it a plus sign or a minus sign? Good. If it's a minus sign, then this is all you got to do. Watch. Just do what I do. When this happens, this is my favorite. I just laugh in my head. Haha. I'm going to beat this problem. 9n, 9n, 11, 11, plus, minus. That's all you do. You see that? Did I do Xbox? Because you're talking. That's why. You kids have to stop chatting. Okay? Again, what did I just do? Okay, I just wrote 2 sets of parentheses. Square root of 81n is 9n. Square root of 121 is 11. And put a plus and a minus sign. That's it. See that? Isn't that easy? Can you do Xbox? Sure, do Xbox. It's just going to take you longer. Yep.
How do you know if it's perfect or different?
Difference of squares is when you have two square terms and just a minus sign in the middle.
So if it's not, so if one of them can't be like squared, then it's different.
Yeah, if there's no middle term and there's a minus sign in the middle,
Then that's different.
yeah. Okay, last one, number 6, go. Last one is 13b. 13b, right? 14, 14, and then you have to have the parentheses, otherwise it's wrong. So you got parenthesis, 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 put a plus sign and a minus sign, and you're done.
It doesn't matter what's under the first and the minus.
It doesn't matter. I usually put the plus sign first and the minus sign second. It just looks neater to me. Okay, that's it. So I'd like you to do this ends lesson.